आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanta Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. In this episode of our podcast, we welcome Dr. Parthasarathi Ghosh from the Department of Geology at Indian Statistical Institute, Kolkata. Dr. Ghosh is a geologist who studies evolution of the Himalayan mountain belt over time. In this episode, Sir talks about the rise and fall of the Himalayas.
Okay, thank you. The rise and fall of the Himalayas. Welcome everybody. I am a geologist and I study evolution of the Himalayan mountain belt over time. We all know about the chain of majestic and lofty mountain peaks that borders the northern part of India. You might know that it is the largest mountain belt on the surface of the earth, a major physiographic feature. It is often called the third pole of the earth. For several decades, scientists have been studying this mountain belt. Many sciences are involved in this endeavor. For years and days, geologists have been constantly studying the rock types, the deformation structures of this mountain belt. Geophysicists are investigating the subsurface and measuring the motion of the plates, and many such things. Some of the important research questions that intrigues a scientific mind are: why did it form? When did it form? How is the mountain changing over time? How does it affect our environment? I have learned some interesting facts about it, and I'm going to share a few of them with you. Let us first talk about the formation of the mountain belt, that is, the rise. When I was young, I used to trek in the Himalayas. Once I was trekking at a high altitude in the Nepal Himalayas. I was walking for some time and was tired. So I decided to take a break and sat down on a boulder. Then I noticed that the rock on which I am sitting is full of marine fossils, the shells of marine organisms. I thought, my God, I am looking at a limestone that formed under the sea. How can a rock that formed at the bottom of a sea can sit at the top of a mountain. You will find these marine limestones at the top of Mount Everest and in the countries of Eastern Europe. Then I remembered what I read in my geology textbook. A long time ago, there was a sea called Tethys. It was lying between the land masses of the Tibetan and Indian plates. About 50 million years ago, the Tibetan landmass in the north and the Indian landmass in the south moved towards each other and closed the Tethys Sea. The edges of the two lithospheric plates buckled and the rocks were uplifted towards the sky. Due to that collision, the upper and lower layers of the Indian plate became detached from each other. It is like the sole of your shoe coming off when you stumble upon some hard obstacle. The lower layer was pushed inward below the Tibetan plate, and the upper layer was broken into large slabs and were stacked one upon another. Each of them are inclined towards north. I hate to say it, but it is very much like those horrible highway crashes where the cars pile up on top of each other. Though we are acquainted with the term Yongfold Mountain, the large-scale organization of Himalayas is more like a stack of slabs actually. Of course, there are innumerable folds and falls within these slabs. So what we get as a result of this big collision? We get the Himalayas, of course. We also get a plateau in the northern side, the Tibetan plateau, a vast flat area lying at an average altitude of 5,000 meters, approximately 16,500 feet, that is above snow line. And we also get towards south a south sloping face or slope where the main Himalayan peaks are situated. And our Ganga-Brahmaputra plains occurs at the foot of this slope. Has the construction of this mountain ended? Oh no, not at all. The GPS data shows that the plates are still converging. It would mean that the mountain is becoming higher and higher every day. So the question is, can it grow indefinitely? The answer is no, not necessarily, because it is also falling. So let us talk about the fall of the Himalayas. What goes up also comes down eventually, isn't it? So you are piling up rock slabs on top of each other. So how high can you make this pile? Just consider Mount Everest is more than 8,000 meters high above the sea level. So at least 8 kilometer thick pile of rock is sitting on those at the base of the Mount Everest. Now the rocks are heavy. Just imagine the amount of pressure they are exerting on the base. What amount of pressure can it withstand before melting? So there must be a vertical limit. If you make a mountain higher than that, the rocks will melt at the base and flow. The mountain will sink back. The most interesting aspect that came out recently is that the processes that build the mountain and the processes that bring it down are closely interlinked with each other. Actually, they are dependent on each other. As per the law of geomorphology, if you make any land surface higher than the sea level, it will be eroded down by the surface processes like those of rivers and glaciers. The higher you elevate the land, the more intense the erosion will become. The huge river valleys that we see today in this mountain belt, like those of Ganga, Jamuna, Koshi, etc., they are the evidences of huge erosion that took place on the southern side of this mountain belt. Again, when you erode it, you are removing material from it. So the mountain belt is becoming lighter, less dense. It will be much easier for the Earth's internal processes to uplift it further. So if we erode it more, we can expect more earthquakes. This is the reason why we are researching to understand this complex interaction between the rise and the fall of the Himalayas. We are using the techniques of spatial data analytics to understand the correlation between these processes. And what are the environmental consequences of the rise and fall? There are too many, but I can mention two of them here. From many studies, we know that before the rise of the Himalayas, there was no atmospheric circulation similar to that of summer monsoon. So because this topographic barrier is here, we get our annual rainfall so we can harvest our food. So monsoon was initiated due to the presence of this big topographic barrier. On the other hand, what about the global warming, the changing climate? Again, the Himalayan mountain belt is made up of rocks, and the rocks are mostly made up of silicate minerals. Eroding silicate minerals requires carbon dioxide. Therefore, these huge valleys eroded from the mountain belt means a lot of silicate weathering has taken place. And that means a lot of carbon dioxide has been drawn down for this process. So, we are drawing down or removing greenhouse gases from the atmosphere in a large quantity. This is possibly the reason for our last ice age and many such things.
Sir carefully explains the significance of studying the Himalayan region.
Why the study of the Himalayan region is so important for us? This is because this region is vulnerable for many natural disasters. You talk about earthquakes, you talk about landslides, flash floods, and many such things. So that is where the importance of studying comes in, because when the earthquakes happen, do they happen randomly at any place on this mountain belt, or they are localized to certain parts of it that can be related with some geological processes? So that is one thing. Another thing is these huge catchment basins of rivers. A lot of rain during rainy season at least gets accumulated in these funnel-shaped structures on the earth. So if you study how much rainfall is happening in which part of Himalaya, that might help to predict the floods in the valleys and also in the Gangetic Plain lying at the foot of the Himalayas.
We feel enriched to listen to Professor Ghosh in this episode, where he shares about his research and its enormous impact on life and environment.